Hi, today we are going to do some sound sampling in Blender 5.2, and our project will be to make a neat little visualization. Real quick before we get started, my name is Ron. I've been a Blender user for about 20 years, and I make immersive content for museums, planetariums, and other organizations. I can also help your team get upskilled in Blender, and we can do that as a team building exercise. It's pretty fun. But let's get started by showing you first the thing that the technical Blender people are here for, and that is the geometry nodes. This is what we're going to be building toward. And if this is all you need, get that screenshot, and thanks for being here. But for those of you who want to hang around, I will show you how to build this out, and we'll try to understand what all the components are doing, at least most of them. So let's also show you what the project is going to look like when it's done, or at least somewhat similar to what we'll do. Let me play this.
You just gotta be fearless. You just gotta be fearless. You just gotta be fearless.
So we've got our audio playing. We've got an analysis of the frequencies, and you can see that the those ratchets up at the top are well separated from those bassy beats down at the bottom, and I really like how the bass kind of rolls around in this song down in the bottom end. Pretty cool looking. So let's build this up. We're going to do a new Blender file. I'm going to save this. And the first thing we want to do is make it so we can hear the song we're working with. So actually the very first thing we want to do is double check and make sure our frame rate is what we want. So I'm not going to do 24 today. Let's do, I'll do 2997. And now let's go to video editing. So that's in the little plus up here. Video editing. And here we are in the video editing window. You won't be able to drag anything to drop it on here yet, but what you need to do is click here, click on scene, and that tells the video editor that you want to stay within the scene that's already established. Now we can drag in our song file. I'm going to put that, bump that right up to the first frame. And I see that my scene is not long enough to accommodate the whole file, so let's find out how long this song is. I'm going to click on the strip properties. And it looks like it ends at 4265. So let's put that in as our end. I'm going to tap the home key to resize the view so I can see the whole thing. So this will play in Blender so you can hear it while you're doing playback. And I'm going to take the volume just down a touch while we're working, so I don't want to listen to that too loud. Maybe half. All right, that'll work. Okay. So now let's go to our geometry nodes. And we're going to add a new geometry nodes system on the cube. So we have our group input, our group output, and we're going to add, so that's a Shift A to add. Let's type in sound, sample sound frequencies. We have this amplitude coming out we can use. Notice that that amplitude is a dashed line, which means that it's giving you the possibility of having a field or multiple values, also known as an array. We'll keep that in our back pocket. Let's add a scale elements. We'll plug amplitude into scale, and we see that something happened. And if we play at this point, we don't get anything happening. So what we need to do is actually rack the time forward. So we can do that by, oops, oh, I forgot we also have to put our song in here. You can either open and find it or click here. And because we added it to the Blender video sequence editor, it's already available to us here. So we can click there. So, okay, now if I go forward and backward in time, we see that we do get a result. So how do I drive this? Well, we can use a scene time node. And we can take the seconds off of that, plug it in here. And now we have a result. So, gonna see where I'm at on the song there. Okay, cool. That gets you pretty far, and you could take and maybe do several of these with different frequency ranges. But there's a better way. There's a way to do this a little more mathematically. So let's do that. First thing we want to do is, well, I've had a lot of first things we want to do here, but the next thing we want to do is get rid of those things. Let's do a Shift A. We're going to add a mesh line. Put it there. And instead of offset, we'll say endpoints, and this will determine the start and end points of the mesh line. Now when I wire that up, we should see a line. Maybe. Well, let's continue. Oh, I went from 16 to 16. I need minus 16. There's our line. Okay. Starting to worry. Okay, let's get some cubes along that line. We're going to instance on points and plug the cubes into this as the instance. So now we have our cubes. There are 10 cubes in a line. We can change that number here, but we're actually going to drive that with an integer. So let's get that. And right now that integer is 0, so let's change that to 32. Okay. Now what we want to do is we want to chop up the frequencies of the song and get this to output those chopped up little frequencies so that we're able to differentiate for these different instances, the bassy ones versus the ones on the high end. And it's easier than it sounds. So let's do a little bit of math. So we're going to take our integer count, which is the count of how many of these things there are, and we need to subtract 1 from that. Math subtract. So we got minus 1. Then we're going to take and divide this by this. So we're dividing 32 by 1. Oh, excuse me, I am doing this wrong. Let me back up. We need an index. So let me show you what's going on here. We're instancing on points, and this is what that means is that we have an individual index for each one of those instances. And if we bring in an index earlier in this pathway, we can say that we are treating everything programmatically different as we go through here, or treating each instance as an individual as we go through the program. So what I was about to do was wrong. let's get the index. And in my mind, I had a 32 because there are 32 indices currently, but that's variable. So the index, notice we have that dashed line. That means multiple values all working together. And let's see. Okay. We are going to use next a couple of things that might not make sense at first, but hang with me. So we're going to use a power math node. The result of this division becomes the exponent of this power node, and we're going to have 1,000 in here. Next, we will multiply. And we will multiply by 20. So let's think this through. If you have an index which could be from 0 to 31, and then we are dividing. We have 32 minus 1, so we have 31 here, and we have something from 0 to 31 here. We're dividing, and we're getting some value out. That value is going to become the exponent for this 1,000, and then that 1,000 gets multiplied by that result gets multiplied by 20. Why these specific numbers? Well, the reason for that is that the human hearing range goes from about 20 hertz to about 20,000 hertz, and that's the range that we're going to get out of this. And we'll get that as individual indices if we are smart about how we handle it. So what we need to do next is we actually have to chop those up. And the way we're going to do that is with a divide and multiply node. And so the divide is going to feed up into the low frequencies. The multiply will feed to the high. And in that way, we will be able to chop up this little song so that we can see the individual components. So let's say that's going to have to go there. All right. Next, we multiply. Or, well, let's divide first. So we're going to plug this in here and this to here. This value is going to be, let's start with 1.1. Now we will multiply. Coming out of the same node, we'll multiply also by 1.1. So this divide is going up to the low value in the sound node, and the high receives from multiply. Now we need to do a little bit of scaling. So let's do that. And we're going to do that with this scale vector. I only want to scale the z direction, but I have a full set of vector input here, a full vector input, which would be like the all three of them, the triplets, or tuple, I guess. I don't know. Let's do a combine XYZ. And what that does is that lets us just put in numbers for X and Y, and then for Z, we can let it be the scale. So make sure those are not nothing. And we're actually in a playable state now, so let's watch it for just a moment. Looks kind of small, doesn't it? Well, we can put a multiply right here and goose those values. You can make this arbitrarily large, just whatever you think you like.
You just gotta be fearless.
Okay, so that's working pretty good. What if I want more space between the lines? Well, that's okay. I could just take this X and make it smaller. What if I want more lines? That's okay. We can come over here to integer and make it more or less. The bigger that is, maybe the smaller this gets. That looks pretty cool. And then these values, excuse me, the divide and multiply values here are pretty good, but those are also subject to change. We could make them maybe 1.01. You're going to get a smaller result out here, so you have to boost the gain. And by doing that, it gets a little more spiky. And that's because we're taking a thinner slice for each one of these instances. So those are some ways to tune it. You can also mess around with these if you want to change the way that the frequencies are distributed. For example, this power, let's set this to 1. You can see how that shifted. Maybe this is 20,000. We're missing a lot of action down at the low end because it's all being bunched up here toward the top. Maybe if this was a multiply, and that song will start once more here in just a moment. Let's get ahead where it's got some more action. So that's another way to do it. If you might like the way that looks better, or maybe someone's speaking and you want it to fill more of the graph. That's a way to do it. This is more of a linear distribution than what we were getting with power. I like power though. And you can see as we drag this multiply value back and forth, we can also tune where everything is appearing. But I like going from 20 hertz to 20,000 hertz. So, I hope that you guys have fun with this. Hope you enjoy. Let me know if you have questions in the comments there, or feel free to reach out to me on the LinkedIn or proctorcreative.com, and I'll be glad to work with you on something. But in the meantime, enjoy this, and happy blending.
You just gotta be